All right, so here's just a little tutorial on how to use the symmetry resources at Otterbein University website. This is an absolutely fantastic website. It's the best way to learn point groups, okay? And so you can go here and go to like the symmetry tutorial. It tells you, you know, symmetry plane, all the things we talked about. It'll help you visualize things, okay? I like the best part about it, that part's fine, the tutorial's fine. What I find the most useful is the Symmetry Gallery, okay? And so you can go through here and look at a bunch of different molecules. So let's look at maybe water first, water C2V point group. So you can wrap it around here. Um, you can uh, you can check, you see the different operations it has as 2 sigmas, okay, and it has a C2, and then it shows you where it is, and you can animate it. So you can see, okay, it's 180-degree rotation, that's kind of cool. You can remove that, and then you can look at your mirror plane, right, and there you go. There's the mirror plane, and then you can say, okay, where's the other mirror plane? Oh, it's in the plane of the molecule. That makes sense. Okay, nothing moves because it's in the plane of all those atoms. But that's kind of cool. And you can go through here. So that's C2V. Here would be C3V. Looks very similar, like ammonia, but you know it has all of them have identity. Of course, you can't animate identity because identity is just itself. But you know you can see it has 3 different mirror planes there. That's kind of cool. Um, and then you know these are all the CNV groups. It has other ones. Let's look at like a more complicated one like octahedral. Okay, so OH, I told you an octagon is OH symmetry. Here's why. Octagon, octahedron, sorry, not octagon. Octagon's a two-dimensional shape. Um, octahedron has, you know, 8 different C3s in it. And so you can see it there. It's going through these 8 faces, octahedron. And so you can animate any of these. Okay, let me try to get just one so you can see it better. So it goes through a triangle. So basically, this point goes to that point, this point goes to that point. This is just super useful site. Um, you can, this isn't a molecule though, this is a 3-dimensional shape. So let's look at a molecule. Let's do, this is probably the simplest one. This is just, you know, a metal center coordinated by 6 carbon monoxide ligands. And so this is very similar. So let's try to visualize some other symmetry operations like inversion. Here would be inversion. So inversion remembers x, y, z going to negative x, negative y, negative z. So you can see they all go through the center because they're getting through 0, 0, and then 0, 0, 0, and then they go to the negatives themselves. So this went to there because it's sort of on the right, so it went to the left. The front went to the back, and top went to the bottom. Let's see, the other one I want to show you was improper rotation, right? Let's do like an S4. So the S4 is cool. Remember improper rotation, like an S4 would be a C4 followed by sigma H. So you're going to do a C4, so a 90-degree rotation, and then you're going to flip across the mirror plane. So it looks like that. Rotate 90 degrees rotation, flip, right? So you can see how, yeah, only the ones that aren't in the mirror plane are the ones that are flipping. If you're in the mirror plane, you're not going to flip. So that's really cool. And then, you know, in the last video, I was talking about some sort of a more rare point groups. That's going to be something like O. Okay, like O is a super strange point group, and you'll see it has still 8 C3s. Okay, this is a crazy molecule. It's a crazy cage molecule, but because of this, you know, these ligands and stuff, it actually doesn't have any mirror planes. So you'll see that there's no mirror planes. That's pretty cool. Icosahedron is, or let's do tetrahedron first. TD, you know, methane, that's TD. So you can see it has a bunch of mirror planes, right? And that's what you expect. It's highly symmetric molecule. But if you do something like T, you know, some crazy molecule, this has the same number of rotations as 4 C3s, 4 C3-2s. By the way, C3-2 means a C3 twice. Okay, so that'd be a 240-degree rotation. It'd be a 120 and a 120. C2 means 180. But yeah, this is a crazy molecule. It doesn't have any mirror planes, so it's point group T. And then there's also point group TH. This just has sigma H's, okay? And so it doesn't have, the 6 sigma D's that TD does. Same thing with icosahedron. These are really rare molecules. A dodecahedron has a icosahedron point group. An icosahedron does, as you might expect. But if you want something that doesn't have that's point group I, they don't even show a molecule; they just show a shape. Okay, and so you can see it has all these C5s and C3s and C2s, but doesn't have any mirror planes. So that's pretty crazy. And then there's like the ones that are less symmetric. So you can look at C1 examples. There's nothing but an but identity there. They also have on this site um, Symmetry's challenge. So you can go here and test yourself. Does this molecule have an infinite rotation axis? Okay, no. And then it'll kind of walk you through. Okay, so anyway, ways you can test yourself, ways you can practice. It's a really, really cool and great resource.